All right, we are going to start 10.2 today, which are arithmetic sequences. So an arithmetic sequence is a sequence in which each term after the first differs from the preceding by a constant amount. The difference between consecutive terms is called the common difference of the sequence. So what makes a sequence arithmetic? Each term differs from the previous term by a constant amount. And we call that the common difference, which is D. So for this first example, you're going to write the first 5 terms of the sequence. A1 is the first term. The common difference is D, which is 20. Oops. Common difference. So if the first term is 200, the next term is 220. See, common difference of 20. Then the next one would be 240, 260, 280. And those are the 1, 2, 3, 4, 5 first 5 terms. So this is A1, A2, A3, A4, A5. And that's example 1, as easy as that. So for example 2 and 3, basically we have this formula here. The formula is for if we want to find the nth term of an arithmetic sequence, just given the first term and the common difference. So basically what this means is if I ask you for the 1,000th term, you're not going to list out 1,000 terms. You're going to use this formula. So I'm going to apply it right here. So we want to find a sub 6. So we'll find the 6th term when you got the first term and the common difference. So a sub 6 equals a1 plus n minus 1 times the common difference. So the 6th term equals 13 plus n minus 1, which is 6 minus 1. So the 5th term, right, times the common difference, which is 4. So a sub 6 equals 13 plus 5 times 4, which equals 13 plus 20, which equals 33. So this formula is for finding the nth term of an arithmetic sequence. So I suggest you pause the video here and try to do this one. The kicker here is that the common difference is negative. So I would pause it and try it. I'm going to go over it right now. So we're going to use the same formula again. An equals a1 plus n minus 1 times d, which is our common difference. So we're looking for the 8th term. So a sub n equals a1, the first term, 4 plus n minus 1. So that would be 8 minus 1 times the common difference, which is negative 7. So that would be 4 plus 7 times negative 7, which would be 4 plus negative 49. I got the negative 49 from doing 7 times negative 7, which is negative 45. And now that's the 8th term. So if you were to do it 8 times, that's what you would get. And that's how you do it. All right, for our next example here, we're given a sequence, and we are going to write our own little formula. So it says write a formula for the general term of the arithmetic sequence, then use it to find A20. So first, we're going to identify 2 as our first term, and then we need to figure out what our common difference is. So if you go from 2 to 7, let's see, that's plus 5, 7 to 12 is plus 5, 12 to 17 is plus 5. So our common difference is 5 here. So what we're going to do is we're going to start with that same formula we used up there. A sub n equals a1 plus n minus 1 times the common difference, and we're going to just plug in what we found. So a sub n equals a1, which is 2, plus n minus 1 times 5. So there you go. Now the last thing we need to do is just distribute and simplify. So a sub n equals 2 plus, I'm going to distribute this 5 here, 5n, and here, minus 5. And now I just simplify a sub n, if I'm off the screen, a sub n equals 5n minus 3. I got minus 3 from 2 minus 5. So again, you just find the first term, find the common difference, plug them into that formula from up top. This is the formula. And then you simplify it. So now we got to find the 20th term. So here's our formula. So to find the 20th term, 5 times n, which is 20, minus 3. A sub 20 equals 97. And that is how you do it. So here we're going to write the formula, kind of the same deal. The only difference here is they don't give you the common difference. They just kind of expect you to pull it from this equation. So this equation is saying the next, whatever term you want is found by doing the previous term plus the common difference. So this is our D. There's our first term. So same thing we just did here. A sub n equals A1 plus n minus 1 times D. A sub n equals A1, which is 6, plus n minus 1 times the common difference, which is 5. So the only kicker between questions here is that they give you the common difference from here, not just telling you what it is. So an equals 6 plus, we're going to distribute the 5 to the n, 5n minus 5. A sub n equals 5n plus 1. There's our formula. Now we are going to use it over here to find a sub 20. An equals 5n plus 1. A sub 20 equals 5 times 20 plus 1. A 20 equals 101. And you are done. So found the formula, plugged in 20, got the 20th term. And there you go. All right, example 6. Find the sum of the first 25 terms of the arithmetic sequence. All right, so this is going to be our sum formula for arithmetic. So if I were you, I would start off in your notes, write it down. So we're just going to start plugging in. So the sum of the first 25 terms, right? N is 25 because they want the first 25 terms. Equals n over 2, so that's 25 over 2 times a1, okay. A1 we get is 7 plus an. Now, wait a minute. An is the 25th term. A25, that's the 25th term. Wait a minute, we don't have that. So hold on, let's backtrack. We got our sum formula. We want to find the sum of the first 25 terms. Are you going to sit there and keep adding to figure out the 25 terms? No. So let's see what we can do. So the sum of the first 25 terms, got that. N over 2, 25 over 2, A1 plus AN, first term plus the 25th term. We have the first term of 7. We don't have the 25th term. So what do? Well, we go back to what we did in the early examples. We use our little formula, AN equals A1 plus n minus 1 over D. We're just going to do a little work on the side. And this is all on the side is to get the 25th term, because we need the 25th term and we don't have it. So A sub 25, I'm trying to write so my hand's out of the way, equals A1, which is 7 plus 25 minus 1 times the common difference. We don't know what the common difference is. We got to look. It's adding 12 times 12. So that's going to give us A sub 25 equals 7 plus 24 times 12. So now you're going to get out your calculators. Again, we're doing this to get the 25th term because it's not given to us. I'll take out my calculator. 24 times 12 plus 7. So the 25th term is 295. And now I can take that 295 and put it there. So the sum of the first 25 terms equals 25 over 2 times 7 plus 295. And now you can just put that right in your calculators. So 25 over 2 is 12.5 times 7 plus 295. Notice I'm using parentheses. You should get 3775. And that's how you do it. So again, you got to do this little sidebar work over here to get the 25th term. But once you do, you just plug it in the sum formula. And that's how you find the sum. All right. Another sum problem is to find the sum of the first 80 positive even integers. So let's just see what we have here. We have to find the sum of the first 80 positive even integers. So I'm going to start by just writing my sum formula from the other slide. So the sum of the first 80 terms, so we got 80 over 2. What's the first 80 positive even integers? The first one is 2, right? Because it goes 1, 2. First one that's even is 2. Now we need the 80th. So if you don't know, it's 160 because you're going every other. So the first 40 would get you to 80, and then the next 40 would get you to 160. So it is 160. But if you don't know that off the top of your head, just come right back to this. I'm sorry, AN equals A1 plus N minus 1 times D. If you don't know that, just come right back to this. A80 equals A1, which is 2 plus 80 minus 1 times the common difference. What's the common difference? If you go 2, 4, 6, 8, 10, all the way up, it's 2. So 2 plus 79 times 2, and that should equal 160. So that's where I get the 160. Plug it in the calculator. 40 times 162, 6480. And that's how you do it. Another example here, find the sum of the odd integers between 30 and 54. All right, so this is a little tricky because they kind of try to trick us. So we're going to come right back to our formula. Sn equals n over 2, a1 plus an. All right, so we're talking odd numbers between 31 and 40. So what's the first one? Most people put 30, but I think I just said it by accident. It's actually 31 because we're talking odd. And what's the last one? 53. So there's your AN. There's your A1. There's your A12. Again, there's 12 numbers because there's 24 in between these. Half of them are odd. So S sub 12 equals 12 over 2 times 31 plus 53. And that should be 504. So again, just to recap, the first odd number between 30 and 54 is 31. The last one is 53, so that's where I got 31 and 53. And then it's 12 because there's 12 in between here that are odd. That's it. We got 2 more. All right, next one we got here is a little word problem. It says a section in a stadium has 20 seats in the first row, 23 seats in the second, increasing by 3 seats each row for a total of 38 rows. How many seats are in this section? So that's basically saying they want a sum of how many seats there are. So let's take a look. We're going to go back to our sum formula. S sub n equals n over 2 times a1 plus an. Let's fill out what we know. The sum of the 38 rows equals 38 over 2. Do we know how many seats are in the first row? Yes, we do. It says it right here. 20 seats. Do we know how many seats are in the 38th row? No, but we do know they go up by 3. So we're going to come over here to the side and try to figure out how many seats are in that last row. So we're going to go right back to an equals a1 plus n minus 1 times the common difference. So there are a lot of formulas in this lesson, but they're all small and easy. You just got to plug the right numbers in. So in the 38th row, we're going to use how many seats are in the first row? 20. Plus n minus 1, so 38 minus 1, times the common difference, which is 3. 20 plus 37 times 3. So we're just going to come right to the calculator. 37 times 3 plus 20. 131. So there are 131 seats in row 38. So that 131 goes here. And now we're just going to type that in the calculator. So I'm going to have 28. Oops. Notice I put everything in parentheses just to be sure that it gets done correctly. And I got 2,869. That's how many seats. All right, one more to go. All right, last one here. It says we want to find the sum of the first 40 terms. So all it is written in that sigma notation. So how do I know it's the first 40? Because it starts at 1, which is, remember, our lower limit from last time. It goes to 40, which is our upper limit. And there's our formula. So S sub n equals n over 2 times a1 plus an. So we really just got to figure out what a1 and an are. I mean, we know that it's the sum of the first 40 equals 40 over 2 times the first term plus the 40th term. But we don't know the first term or the 40th term. So how do we get those two? We have to use this right here, this negative 2i plus 6. So over here, I'm going to find the first term. I'm just going to do negative 2 times 1 plus 6. Negative 2 plus 6, which equals 4. So that means the first term is 4. A1 equals 4. Now we do the same thing with 40. A sub 40 equals negative 2 times 40 plus 6, which equals negative 80 plus 6, which equals negative 74. So A sub 40 equals negative 74. So just to recap, we got to find the sum of the first 40. We don't know the first term or the 40th term, so I use the little sigma notation to find it. So I plug 1 in for the first term, get 4, plug 40 in to get the 40th term. So now I can finish the formula. 40 over 2, 4 plus negative 74. And you're going to type it in your calculator. 40 over 2 is 20 times 4 plus negative 74. You get negative 1,400. Those are your notes. Now you guys can do the MyLab assignment. And that's it.